Explore and understand these four piecewise functions with us. Thank you. Welcome to another important video in our series of domain and range of functions. In this video, we are going to explore four piecewise functions. In the process, we will understand how do we graph them. Once we graph them, then domain and range becomes absolutely clear. We'll follow very simple steps so that each and every subscriber can understand what are we doing to find the domain and range. I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We have been serving you for last 15 years absolutely free, and I'm very thankful to all the subscribers for watching the videos, promoting our videos, and providing excellent suggestions. Now, let's look into the solution of these four questions one by one. What solution I really mean? Let's try to understand each and every function, graph them, and find their domain and range. You can always pause the video, answer, and then look into my suggestions. So let's begin with the very first piecewise function in which we have combination of a linear function and a quadratic function. So let's look into this. We'll make a table here, right? So we are given f of x is equal to x plus 1 when x is greater than 0. So you could think like this. So it has two parts, two pieces. When x is greater than 0, in that case, the function is x plus 1. And when x is less than 0, then the function is minus x squared. Get an idea. So just for a rough sketch, x plus 1 means a straight line and minus x squared means a parabola which is going to open downwards. But we are only looking to a restricted domain for each one of them. So let's try to sketch it here. So x plus 1, as you know, is a straight line. To sketch the function x plus 1 when it is greater than 0, one thing which you have to notice is that it is not equal to 0, right? So there's a hole at the beginning when x is 0. So if I put x as 0, then I get 0 plus 1 is equal to 1. So we have a coordinate point which is 0, 1, correct? So that point I could substitute here, draw as a hole, right? And then to draw a straight line, we basically need to figure out another point. So let me put x as equals to 1 and 1 plus 1, as you know, is 2. So we get a coordinate point which is at 1 the value is 2. So at 1 the value is 2. Joining these two, we get a curve which is a straight line, and there you go. That's our function. Clear? So this is the graph of a straight line on the right side of the y-axis. Now on the left side, we have minus x squared. So of course, at x equals to 0, what do we have? Well, minus of 0 square will give us 0 itself. 0 is no sign, right? So we do have a point at the origin, but this is again a hole. So we have a point here. Let me sketch a point here at the origin. And this is the vertex which you can see at this point. And then the graph, when I take this as minus of minus 1 whole square, that gives me minus 1. So the other point here is that at minus 1, I have minus 1. So, and the shape of a parabola, this is kind of important, right? So that becomes the second piece where the x is less than 0. So that's what you get, the graph of the function. Let me now label this as x-axis and the y-axis. So that becomes our function f of x. Now you can easily write the domain and range of this particular function. Clearly, what is a domain? Well, I'm writing domain with letter D and X in brackets, and domain, as you can see, X belongs to real numbers. However, X is not equal to 0, right? Since the function is defined, either X is greater than 0 or less than 0. So X is not equal to 0. As far as the range is concerned, I'm writing R, Y. What values can Y take? Domain is what value can X take, right? So along the y-axis, you see there is nothing in between 1 and 0. So we know that y belongs to set of real numbers, right, where y values are either less than 0, right, they're not equal to 0, or they are. So or can be written as union y is greater than 1. Is that clear to you? And that is how we can write domain as well as range of the function. The graph makes it absolutely clear for you to understand. I hope it makes sense, right? Have a good look at it. And once you have seen how we should do it, you can move forward and answer the next question. Well, those of you who really want to learn and excel, learn from me and excel, can always send an email on globalmathinstitute at gmail.com. Our students are right there on the top, getting admission to the best universities, even with scholarships. So here is your second function, g of x equals to 1 over x minus 1 when x is greater than 1, and is minus of x squared when x is less than equal to 1 this time. You get the idea. Perfect. So you have the concept. Let's make a framework here. So as I did earlier, we will see what is the type of graph when we're looking for x greater than 1 and x less than equal to 1, right? So this less than equal to mean filled in circle. Greater than means open circle, not included. You get the idea. So you see this is a reciprocal function, 1 over x when x is equal to 1. We have a vertical asymptote, right, for this particular function. So when I sketch a graph here for this particular function on the right hand side, we know that at 1, which is not included here, actually there is a vertical asymptote, right? As the value of x increases, this curve actually can be seen as shown here. You get the idea. So that is on the right side of 1. Now on the left side of 1, we have minus x squared, right? So points matter. So you could actually have some points here. So if I write the value as, for example, 1, right? So we have a vertical asymptote at x equals to 1, which is not included in the domain for sure. And if I write x equals to 2, then we have 1 over 2 minus 1, which is 1. And therefore, we do have a coordinate point at 2, which is 1, right? So at 2, we can say this point here represents 1 for us. And then you can take some more points. You also know as x approaches infinitely large value, y approaches 0, but from positive side. So it is always positive as shown here in quadrant 1. Makes sense, right? On the left side is the same function, minus x squared, right? So here, if I substitute 1 here, right, it is less than equal to 1. So I know for 1, I'll calculate this and be minus 1. If I put this as 0, then at 0, I have 0. And at minus 1, what I get again is minus 1, right? So we do have a vertex and the other part of the graph. Let me change the color. Okay. So will be like this, right? We have a filled in circle at 1, right? So kind of like this. Makes sense. So that becomes the graph of the function on the left side of 1. Perfect. Now, from the graph, I would like you to write down the domain and range of the function. So let's write down the domain first. Domain I'm writing as d of x. All the values can be taken by x, the input values, right? So we can see from here clearly that x can take all the values, right? X belongs to real numbers because at 1, we have given it a value which is minus 1, right? Make sense? Now, as far as the range is concerned, the y values are y does belong to real numbers. However, there are few values which it cannot have. And is there any value? Well, none of them, right? All are there because at 0, we have a 0 here, and the other graph on the right hand side is always positive. So, x belongs to real numbers. There are no restrictions on this particular function as you can clearly see. Perfect. So I hope the concept is clear. Let's move on to the next question. So here is question number 3, where we have taken up square root function this time to work with. I'd like you to pause the video, answer the question, and then look into my suggestions. Those of you who want to join our classes, feel free to send an email. We also conduct group classes during the holidays. So inquire by sending the email. One-to-one classes are always available, so join whenever you want. So now we are given a function h of x equals to square root of x plus 1 for x greater than 0 and minus x plus 1 when x is less than equal to 0. So we have two types of functions. One we have on the right hand side, which is a square root function, which can be shown like this. And then we have minus x, means a line which is going downwards, correct? So these are the two functions we're talking about. And well, these are square root of x plus 1 when x is greater than 0, and it is equals to minus of x plus 1 when x is less than equal to 0. So let's try to sketch them first on a graph. Take some points, at least 2 or 3, for each side to get a good graph out of it, right? You know the shape of the graph. So at 0, the value will be 1, as you can see. So what is really happening here is that your normal graph, which was square root function, has moved left by 1 unit, right? So at 0, we have a value which is 1 and it's a whole, right? So it is a graph like this, where at 0 we have 1. This straight line, if I substitute 0 here for x, I get 1, right? So let me use another ink here. So at 1, we have a continuity. And then if I put minus 1 here, we get 2, right? So this is a graph which goes like this. Do you see that? So that becomes the graph of this particular function, h of x. Now it's very simple for you to write domain and range. So I'd like you to pause the video, write down the domain and range of the function. So domain for us is absolutely clear, which is x belongs to the set of real numbers, right? As far as the range is concerned, y values you can see are always greater than equal to 1, right? So we can say y is greater than equal to 1. Is that clear to you? So with that, we have done 3 questions, piecewise functions for you. And the fourth question is like a test problem. So this time we have a question which is kind of a test problem, very difficult to do. So as compared to the previous 3, of course. So what we have here is a parabola on the right hand side, right? So I like you to attempt this question and I'm going to provide you a solution in the next video. Now here you see on the right hand side of minus 1, we do have a parabola, right? So I'm just saying it could be a function which is, could be like this. And then we have an absolute value function on the left hand side. So it is kind of like this, right? So these are the two functions which we are talking about. Take some points and sketch them. Once you sketch them, it's very easy for you to find domain range. Perfect. So I hope the concept is clear. Provide the solution, and in case you have any difficulties, you can write in comments. I'll also provide you extended solution of this particular problem in the next video. So, Epi, thank you once again for your valuable time, and I hope you're taking something from this video. Thanks a lot, and all the best.